This lesson, Algebra Half, is extremely visual. It's really going to require you to read through this lesson to see all of their examples. I did my best to replicate some of the types of graphs we're talking about, but you're going to need to get practice making these yourself too, and reading and supplying different types of answers for different types of graphs. You just can't know everything there is to know about graphs and reading graphs from just 2 graphs and a short 5-minute video made by me. So keep that in mind. Keep in mind that reading and interpreting graphs is a gigantic skill, not just for math, but for science, and on your standardized tests. You're going to encounter this all the time. So it really is a good skill for you to feel comfortable about, and not just sort of, oh, well, it's kind of like math, but it's also sort of science, so I don't really need to know it right now. You absolutely need to know this. There are 2 types of graphs, first of all, and if you had to tell me what type of graph is this, you would say, well, these look like candy bars, different sizes. This guy's lucky, he gets a big one. So these are bar graphs. Now, what does the data look like on this one? Kind of like just a line, not a bar, but is it a perfectly straight line? Is it just a line graph? No, it is a broken line, right? Broken at different spots because it's data points in different levels. They can both show similar or same data, but shown in different ways to give you a different feel. This feels more like it's telling me amounts. This more shows better with a change, I think, progressively through time. So you choose ones that look better for the basic data you are using. So if they ask you simple questions like, how many more students are born in June than in May, you look at your, what's this axis? The y-axis is the one that goes up and down. The x-axis goes horizontal. So the y is telling us, check out the label, how many students, and the x is labeling them by the month of the year they are born. And the title of the graph is very important, neatly written at the top, birthdays for students by month. Okay, so we look to the month that they started with. They said how many more in June, and we say, okay, there are over 10 in June, and in May there are over 8 in June or in May. So to answer that question, we simply find the difference, and there are 2 more students born in June. Okay? If you were to draw these yourself, what do you think are some of the keys I'm looking for to get it right? Because I will double check these even after you correct them on your homework to make sure you're good for the test. I can think of at least 3 things I want to see. I want to see that you're using a ruler to make these lines straight. Gone are the days where you could get away with a graph that looked like this, and that's a bar graph showing me roughly 5 as opposed to no. That's not good enough anymore. I need rulers fit into the box, or otherwise use a side piece of lined paper. Or you have big boxes for work, and just refer me to the box for work. Take your space, neatly do it, plan it out, because the next part is that they are evenly distributed, that these are all roughly the same distance apart, that they don't look all, this is really close together, and then this next one's really far apart. Evenly divided. Same on the x-axis, that these are equally divided. So it looks neat that way. So neat lines, even divisions, and then I want your lines to go all the way down on each measurement. Not just a notch right here, but all the way down. How does that help the reader of the graph? Well, remember when I was looking at students in June, I had to follow it over to 10. And if this line weren't here, I might follow it down to 8, and everything will be screwed up, and I won't have an answer. So 3 things in your graphs: ruler, equal divisions, both x and y, and lines horizontally across the graph from each on the y-axis. Okay? How about if they gave us different data points as far as magazine sales per day, and Monday is, see how this could actually be turned into a bar graph pretty quickly? See, it's doing the same thing. It's just showing it as equal data points. And what if it said, there were 45 on Wednesday, there were 23 on Tuesday, and exactly 20 on Monday? If you had to show a graph, you would draw one like mine. If you had to read my graph and it asked you how many more on Thursday than Monday, you take the difference of 50 and 20. If you had to say how many magazines were sold in all, you would add up all 5 of my data points for that week. If it asked me how many on average were sold each day of the week, how would we solve that? We would take my 5 totals, add them up, roughly, let's say it's 80. I'd have to check. 80 divided by what? By 5. Average magazines sold per day of the week would be, I was going to say 40. That's 200. 80 divided by, let's just do it quick. I'm drawing a blank. 16. So on average, 16 magazines sold per day. Average. Okay? So we can use this to solve average problems. Check out the practice letter A problem and show me that one to show that you can solve average when they're even showing multiple amounts, different types of cars, cars A, car B, and car C for different years. And they're going to ask you, how about type B over the 3 years? So now they're differentiating that there are 3 types within. Okay? See if you can solve that. And then check out example 29.3 quick for pie graphs. I feel like we know those well enough. Finally, after you've done practice A, I want you to build one of these 3 types of graphs following all the rules I said and show me surveying the class for their birthday months. A class birthday month graph. Shown any of the ways that we've learned. 2 things to do before the lesson.